Şimdi sözü Xicato'dan Roger'a bırakacağım. Biraz bu kavramlar üzerine Xicato kablosuz Bluetooth aydınlatma kontrol sistemi adına ve nesnenin interneti adına neler yapıyor? İçinde demo barındıran hem de bilgi barındıran bir sunum yapacak. Sonra ben tekrar geri geleceğim. Roger.
Roger and Emre, that's right. Okay. So thank you very much indeed, Emre. I'm happy and honored to be here in Istanbul. And Emre briefed me that I should give a brief introduction to smart lighting. Well, this is quite hard to do in 30 or 40 minutes. It's like trying to plant an oak tree in a plant pot. It's just such a huge topic. And the way I decided to structure my talk, sorry, I lost my pointer, here it is. Oh, you took it, come on. Is to, first of all, talk about a starting point for what we know as smart lighting, because it didn't just drop out of the air as one fully formed concept. It's step by step been evolving in this direction. Then we will take a deep dive into communication itself, so already some of the terminology Emre has touched upon. Then we will roll up our sleeves and see smart lighting in action, both in terms of some functionalities, I've got a few demos here, and also in terms of some real-life testimonials. Then I will wrap up with a summary and hand back to Emre again for some product talks. So the starting point to smart lighting, I always like to begin with the concept of the light quality itself. So you can have smart nodes, but yeah, maybe you can communicate with the light with your smartphone, or it auto-corrects to common faults and this sort of thing. But if the light quality is mediocre, then I would argue it's not so smart, is it? And I think the two main areas that you look into are the consistency of the light source. These are two shops near Green Park, where I live in London. And you'll see that one with this color point inconsistency, the shades of green and pink in the wall washing, the scallops, and here a much better performance. Well, where would you rather buy a handbag from? Isn't the image of the store tarnished with this one? And I would recommend a good 360-degree metric around a target color point, such as macadam ellipses. Don't accept half answers like delta CCT, etc. And then we have the accurate color representation. So here we go into not the look and feel of the space, as with color appearance, but how are colors rendered. This is a hotel in London where I worked with the owners, and they were looking into replacing halogen lamps in all the corridors. And I said, let's make a mock-up in two identical corridors. And with this one, we had lighting of a very high color rendering. The color rendering index was about 98. And here, the color rendering was lower, about 85. But the energy consumption was also lower. It's a trade-off, I can't help it, this is physics. So here you get about 25% higher efficacy. But I said, look, with all your fine hardwood doors and architraving and Axminster carpets, isn't this more the solution you're after, which is the one they went for? So again, I would recommend all-encompassing metric. This is the one from the IES TM30/15, which has 99 color evaluation samples. There's really nowhere to hide. It's not 8 or 14 or 15 color evaluation samples, but 99, as shown here in that color vector graphic. So I would always say light quality is the starting point to smart lighting. The second theme that's been ongoing is that of integration of functions. And I think it was Steve Jobs that really paved the way here when he said an iPod, a phone, and internet mobile communicator, these are not three separate devices. So thus, since then, I think it's, I don't know how many million, or I think it's over 1 billion iPhones have been sold because it's really improving people's lives. So what has the lighting industry done on this theme? Well, if you look at a typical smart module, that you have the light engine, but you also have some electronics inside. And if we break it into boxes, you'll see that we have the LED engine, if you want to call it that, but also a dedicated driver, so that you have maximum efficiency. We have sensors, both inward-looking sensors, so diagnostic sensors, monitoring the operation of the smart module. If it gets too hot, then it's compensated for. The current is lowered. It could also be outward-looking sensors, monitoring environmental conditions, so you have adaptive environments, adapting to people's presence, adapting to incoming daylight, etc. Well, it's one thing to have sensors to measure these parameters. It's quite another to do something about it. So a smart module such as this must have a brain, if you like, or microcontroller, that it can actually take this sensor input and do something about it. So the example I just gave, if somehow the temperature is too high, it could be a perfectly well-designed downlighter, but it's been put next to a hot water pipe or something. It acts accordingly. It will lower the current. And finally, connectivity. Here I've diagrammatically shown it as a circular antenna, and here is indeed the main theme of wireless communication. Capabilities have gone up, prices have come down, and the whole thing has become realistic. So before I go on to go into a deep dive on communication, let's just look again one more time at the actual driver within the smart module. There's a couple of obvious things. If you don't need a separate driver, then you smarten up the track. You don't need the driver here. It's like the old halogen J's, just plug it into a track. But secondly, it means critically with the dimming performance, as you've matched the actual LED array with the dimming circuitry, you can have perfect flicker-free dimming down to a low level. And here you see I detail deep dimming to 0.1%. Maybe you see on a spec 1% dimming or 0.1% and think they're quite similar, but in fact they're not at all, because if you look at this phenomenon known as Stevens' law, if you have dimming, actual dimming to 1%, what the human eye actually perceives is still over 20%. So if you really want dimming to darkness, you need dimming down to about 0.1%. And the other effect of really tuning the electronics in the dimming circuitry to the LED array is that this dimming can be flicker-free. I don't just mean visible flicker, this would be terrible, but I mean non-visual, flicker that bypasses the visual cortex. And you see when you're dimming LEDs, you use constant current reduction down to a certain point, about 20%, and then you have to chop the waveform. It's called pulse width modulation. If you can control the driver, tune the driver to the LED array in terms of the frequency and the modulation, you can make certain there's no flicker, no non-visible flicker. And you might think, well, I don't care. If I can't see it, it can flicker away. But the point is that there's plenty of literature linking non-visible flicker to headaches, eye strain, insomnia, etc. And all this becomes possible with the integration of components within a smart module. This diagram shows you the thermal foldback that I mentioned earlier. You have a threshold temperature, in this instance 93 degrees. If the actual temperature picked up by the thermistor on the LED array exceeds that, then the microcontroller, over 60 seconds, lowers the current. Okay, so this is a kind of build-up. This is what's been going on in the industry for about 10 years. And now we get to communication and the, let's say, the giant strides that are being taken now. Before I get into the nitty-gritty, here's a helicopter view. So here, as Emre defined them, a series of smart nodes. And notice this is not just about brightness control, but also other, think in terms of smart buildings, not just smart lighting. So it could be heating, ventilation, security, movables, etc. And what's happening is you have a series of smart nodes, if you like to put it figuratively, having a conversation with a lit space and responding on what it hears and responding autonomously. It's not waiting for some Dali master to give it a command. If it sees how many people are in a room, what are those people doing, how much incoming daylight is there, what's the temperature, etc., and autonomously makes its own decision immediately with no latency effect, how to keep the environment in an optimum situation for the people in the room at a minimal energy consumption. So if you like, it's anticipating the lighting that's needed in a given space and acting upon that. Of course, you can have this automatic layer and a second layer of control via switches, sensors, or apps, which I'll demonstrate in a moment. So that's the big picture. Now I want to recap on the protocol involved. So here is exactly the same mesh of smart nodes, but this time shown diagrammatically. And here you see the lines of communication between the different nodes. And obviously, for this to work industry-wide, it cannot, there must be open standards that all the manufacturers can work to and provide interoperability that, for example, lighting designers can have one interface and behind it different manufacturers, wall wash or track spot or pendant, etc. Now, there's a number of wireless protocols. Emre mentioned them, Zigbee, Z-Wave, the Thread Group. I want to talk about Bluetooth now, which I think has some unique advantages. As Emre already built up the story, just to be clear that there's no confusion between classical or basic Bluetooth and Bluetooth low energy. It started with this point-to-point topology, so the whole discussion is between, for example, a phone and a headset. So you can have large amounts of data transferred. It's not worse than Bluetooth low energy, it's just for different functions. It was developed for audio. And yeah, this means that the whole discussion is point-to-point, and if you move out of range, it stops. And next came this star topology, Bluetooth mesh, and this is different, so you can have one hub talking to any number of peripherals, and it's now you can't talk about audio or large data packets, 20 megabyte files or something. It's very small status packets. So this, for example, would be used for the beacon app type applications that Emre mentioned. And it means it's, you know, it's not when the peripherals have something to say, then they broadcast these small packets, and it means it's very low energy, and if you're running them on batteries, they can last several years. And what's coming next is the mesh. So this is one-to-one, this is one-to-many. A mesh, if you like, is many-to-many. So all the nodes are talking to each other, and the beauty is that there is no hub. There is no one single point of failure. The Bluetooth mesh standard was published in July, so it's available. And the industry is getting to grips with it. And I promise you that you'll see during 2018 more and more Bluetooth mesh-based products on the market. So the Bluetooth mesh, my company was part of the working group from the special interest group which runs Bluetooth. And it was designed with commercial lighting in mind. And I'd like to bring out three key factors behind that comment. One is interoperability, the second is scalability, and the third is robustness. In terms of interoperability, what's important is that the whole standard is, the whole stack is standardized, the whole OSI stack. This is just a model to describe what a protocol does. So, for example, you could have a physical layer, which is the frequency, and you could have a network layer, which is how to address the message that they reach their destination. And critically, in the context of this discussion, the application layer. What is the message? So turn on, turn off, dim up, dim down, preset 1, preset 2, activate this group, color change, what have you. And with other protocols, the application layer is left to the manufacturer. With Bluetooth mesh, the whole stack is standardized, so this leads to interoperability. The next point is scale. If you have a many-to-many network, this means you're quickly reaching the extremes of very large areas. So this is what you need for, you know, if you're talking about shopping malls or this sort of thing. And secondly, because the data packets are so small, that you can, you know, it's scalable to thousands. I wouldn't like to try it, but as Emre said, theoretically 32,000 nodes, similarly groups or scenes. So if you look to buildings of the future where above the ceiling it's like an information highway, sharing information, mapping them to algorithms and you know, the whole smart building vision, you need this kind of scale. It's going to go well beyond what we think of as smart lighting now. Bluetooth mesh allows this. Then in terms of robustness, a key thing is that you don't get congestion. What helps is the speed. As Emre said, with Bluetooth 4, it's 1 megabyte per second. Compared with Zigbee, it's 250 kilobytes per second, for example. Oh, I didn't mean to do that. My apologies. It's also channel hopping is relevant here. So there's 40 different channels, and the actual message can hop to the least congested one. And finally, the not ad infinitum, but messages are repeated in case it doesn't get through for the first time. So all this increases the robustness. Secondly, remember it's multicast, multipath. All the nodes are communicating with each other. This means, let's say that node fails, node 10. So 8 can't communicate with 11. Well, it can, because it just finds another way. This is what I mean by self-healing. And this red line is supposed to indicate a wall. Let's say you're working on an old castle, which is an obvious application for this kind of wireless technology, because you may be not allowed to drill through walls. So here's an example. Yeah, Bluetooth would be severely attenuated if it was a 2-meter thick granite wall. Well, if that node can't talk to that node, it goes this way. So you can deal with complex layouts. And I think most critically is the lack of a central controller. It's inherently robust. There's no one point that can fail. And also, as Emre mentioned, a key point about Bluetooth, which is not true for any of the others, with the exception of Wi-Fi, but that certainly would have a latency effect, is it's in everyone's pocket. It's in smartphones, it's in tablets, etc. So it's being propelled forward by the big names in the industry like Apple and Google and so forth. And this is great for our little lighting industry, because it means costs will come down, and at the same time functionalities come up and it will become lower energy, etc. And secondly, the tool support. So the actual operating system within the smartphone itself you can use if you want to develop apps, which I think are so important for control, to make the whole thing intuitive. My wife's a primary school teacher, and from the age of 4, children are learning how to use apps. And yeah, I think this takes away a major hurdle to controls adoption, that usage becomes intuitive. Okay, so much for the theory and build-up. Now let's look at it in action. I've taken a few snapshots and tried to make it as realistic as possible with application examples. So firstly, if we look at control panels, with which you can recall scenes. So for example, this is a ballroom in a hotel, and it could be used for having a conference or a party or dining or entertaining and so on. And then each would want a different lighting setup. So easy as the front end of the wall switch or the touch panel on the wall is, it must be intuitive and easy to create these groups. So what I've got here is a couple of light sources, a linear one and a point source. And I've got them connected to a control panel. So it's, there's some other Bluetooth devices in the demonstration at the back. But here you can see it's CPD3 and CPD1. And if I go to groups, you can see that I've put them in this group. So I can test it. You'll see they're flashing. And in terms of scenes, I made a scene called 20%. I lack imagination. And again, I can press test. And if I go to the dashboard, you'll see they're now both at 20%. But in fact, that could have been a scene called dining or dance or what have you. I've been in the lighting industry 30 years. This is nothing new. What is new is how easy and intuitive it's just dragging and dropping nodes into groups or scenes to achieve these ends. Okay, I'll come back to this control panel to show you some other things by and by. This is the another way of controlling the light. Instead of using a control panel, using an app on a phone or tablet. This happens to be the, I forget the name of the exhibition about La Belle Époque, in the Van Gogh Museum in Amsterdam. The fittings involved, the track spots were made by Mike Stone Lighting, and actually they're at the back. Emma's put them as part of the display. There's 1,300 track spots in there. And I was privileged to see the head curator actually doing the commissioning. And he did it, actually it wasn't his phone, he used a tablet, and just went one to one to one with this virtual slider, setting the light level he wanted for each one, then press, he made a scene, and that's it. And when the exhibition changes, it's just as easy to change it around. So now I'm going to take my life in my hands and try to show you that app. No, it's okay. So here you see it's picked up. There's a couple of groups.
Just
say
no. No, just say no.
I haven't got to that bit yet.
I will show later. Just a quick note. Xicato'nun aplikasyonu herhangi bir ücret talep etmiyor. Şu anda bile iPhone veya Apple tabanlı bir telefonunuz varsa indirip arkadaki ürünlerle etkileşime geçip kısıp açıp oynayabilirsiniz. Ara bir not olsun. Please go on.
Okay. For all I know, I'm now going to say exactly the same as what Emre just said, but if I click here on public, you can see that I'm now controlling via the app this group that I made. Actually, while I've got the app up here, I can show you a few other things. One is that I can get all the facilities management type operational data from the app. And a second point is that very important is the whole issue of security. Not so much the transmitted data, that's pretty well encrypted. Emre mentioned the AES 128, but even at device level you can set a ID and password to protect the whole thing. Okay, So the next snapshot I will make is one quite often used in the homes. This home uses about 200 smart light points, and they're controlled with, maybe you don't want in your home to use a phone or a touchpad, just a straightforward switch. And here you can see that I'm switching these light points or dimming them to a point that I want using a switch. And the beauty of this switch is not just that there's no wires, there's not even a battery. It's from a company called Ocean, and it's energy harvesting. So, you know, it's converting the kinetic energy of my finger press into a Bluetooth signal that's doing this.
Another quick note.
Yes.
Şu parmağımın bastığındaki kinetik enerjiyi elektriğe dönüştürüyor. Bu sayede herhangi bir switch'i enerji kablosu bile çekmeden kullanmanız demek. Ve arkasındaki Ocean Bluetooth üzerinden konuştuğu için, protokol aynı olduğu için bir yandan daha sonra kullanacağınız veya hiç daha önce planlanmamış çeşitli senaryoları elektrik kablosu bile çekmeden uygulamanız ve hayata geçirmeniz mümkün.
Correct. Now I come on to the subject of sensors and learning environments. And here you see a picture of a museum. It happens to be the V&A in London. And yeah, you can see with the north lights that there's daylight coming in, which you can harness, so lower the light level of the artificial lighting if there's sufficient daylight coming in. And this is done with simple if this then that programming between the smart module and the sensor. So it's programmed, do I listen to gallery 1, sensor 1? Yes. What do I do if I'm triggered by a signal? I go to 80% intensity. So again, I've made a little demo for you. And if I go back to the control panel and I go to the sensors page, you can see that for, I will just do it for CPD1, get. You'll see that I've taken a, it's in yellow because I haven't put the battery in yet, but I've taken a motion sensor, M0, and said that if it detects an event, i.e. motion, it goes to 20% flux, fade time of 3 seconds, no delay. And then if after 10 seconds there's no motion, then it goes off. So what I've got is indeed such a sensor. And I didn't have the battery plugged in, or it'll go up and down and get on my nerves. But I'll plug the battery in now. And you will see that if I go to the dashboard, as I programmed, it's gone to 20%. Look at CPD1. And after 10 seconds, that will go off, which doesn't seem very long, but when you're in front of so many people, it is a long time. So it's now off. It's a kind of a trick demo. You knew exactly what you were going to see. And I repeat what I said earlier. This is not new. It's just doing better what the industry has always done. More intuitive, cheaper, faster. Another point is information retrieval. So I can get instantaneous information on all the things critical to the health of my module, such as electrical parameters, thermal, etc. And here you see that all the dials are in the green. But imagine that one went into the red, the thermal, for example. Just like if your oil pressure is too low or something in your car, you get a warning signal on the dashboard. Here it could be you know, an email or something to a facilities manager. Or it could be you pull from the microprocessor historical data. Here's a histogram showing hours or weeks or months of operation at 50 degrees or 60 or 70 or so on. And if I have this exact data, then it's possible to give extended warranties on LED modules. Let's say it's a high ceiling and you need a scissor lift for maintenance and you want a 10-year warranty. Previously I would have said, well, 10 years is a long time, but if it's really based on actual data and there's an agreement with the luminaire manufacturer that, let's say, the case temperature won't go over 80 degrees, then the whole thing becomes really realistic and based on actual data. So again, I can give a quick demo. If I go to the control panel and I go to the log page, then here you see a real-time graph. So the yellow line is intensity. It's where I was switching with the sensor. That's the overload temperature. There's the actual PCB and LED temperature. And if I look at, for example, the histogram that I mentioned earlier, there you see, since I used this demo module for the first time, the spread of temperatures that it's been operating at. And the same information I can get actually remote from the site if I use a gateway. A gateway you can think of as being a translator from Bluetooth to Internet Protocol. So here you have it on a local area network, but if that's bridged to VPN, then anywhere in the world you can get operational data. And this is important. Can you imagine, for example, a hotel chain that from one central point, could be globally, you're picking up all this kind of information. It could be at a higher aggregate level, and then you work down which hotel, which room, which light fitting, etc. Then you only have to go on site once, and you've got the right thing in your bag to do the maintenance. So here this is a shop where I was commissioning last week, and you can see that the atrium lighting, there's something in red, TOV, that means temperature overload. So I knew where there was a problem in advance and knew what to do about it. Again, I can give a quick demo. So here you see exactly the same information, and but this time it's coming through the internet. So if I go to, you see that I'm flashing the group that I made, and then if I go to show controls, I can switch them off, or I can, a small delay there with the internet. So that might have looked unimpressive, that demo, but actually it's quite good that I'm doing this through the internet, and I could have done exactly the same thing if I was the other side of Istanbul. And finally, this topic of beacons, which I like to introduce as another example of integration of functions. So you have luminaires not just giving light, but performing other tasks as well. So the way it works is that you, for example, in a gallery, have the track spots around the exhibition areas, and they're each sending out this Bluetooth signals. It's exactly the same as the way I picked up the operational data just now, but here, if it's triggered, so via triangulation, the app is comparing different received signal strengths, and if triggered, I get information. It could be on wayfinding, or it could be merchandise in a shop, or a picture in an exhibition, etc. Now, what I've got to demonstrate this is, again, I'm going to take the chance that this works and plug in my phone. And what I'm going to show you is a beacon app that was made by a company called Llama Digital. And it was made for a museum of Egyptology called the Petrie Museum in London, in Euston. And so if I enter the app, and well, it does a lot of things, but just to show you one thing. So here's the floor plan, And do you see one light, one is flashing? And it's because I've provisioned one of those modules to think that it's at that place in the Petrie Gallery in London. And then if you click on that, then you get information on what you happen to be looking at. It's a very interesting gallery, by the way. It's the biggest collection of Egyptology apart from the National Museum in Athens. And this leads me to the final point, that it's not just about lighting, it's also about data logging. So every time that app is triggered... Sorry, I'm laughing at my own stupidity. Okay, I was wondering why no one was looking at my slide. So this is the Petrie Gallery, and the point of this slide is that every time such an event happens, triggered by the beacon, then it's logged onto a server, and then the owners of the gallery know exactly where people go, how long they linger, and you can manage your assets better in this way. If there's areas that are underutilized, then rearrange things. Also, you can compare footfall with weather conditions or other events happening in London, or what's happening with transport. And generally, it's all about increasing ROI. So for my final slide, I'd hate to walk off this podium with you to think this is the future. It isn't, it's now. Where I mentioned big data, that's going to change a lot. Just watch that move. But in terms of the smart lighting, here's from the UK some lighting used in tourism and Birmingham University, a big department store. This is a church in Sydney, a home in America. That's a restaurant in Melbourne. This is the V&A. The Van Gogh Museum in Amsterdam. There they've got more than 200 sensors. This one I took from the V&A. It's plugged up in the track, and it's all for energy saving according to is there people in the hall or incoming daylight, as well as conservation issues and monitoring light on the paintings, which could make the pigments fade if unchecked. This is a big department store in Bracknell in the UK. It's the one I was working on this week, actually. And the atrium lighting, if the incoming daylight, so there's a sensor like this. If incoming daylight increases, then the atrium lighting decreases, and the shop window lighting increases for pulling power. This is for energy saving. So to summarize, I would say it's changing the controls equation completely. Fast, easy, and affordable. It takes days and not weeks to do this kind of installation and commissioning. Industry-leading performance. You have peer-to-peer communication and responses. You've seen them with sensors or switches are instantaneous. Unlimited, almost unlimited scalability for large installations. Literally thousands of nodes or groups or scenes. And if you want more, you can use a gateway to bridge different networks. Fully automated lighting, so schedules and sensors can make certain always the lighting in an area is optimum. It's inherently reliable. There are no wires or connectors or hubs to break down. Beacons for location-based services increases the functionality, the possibilities of usage of luminaires to location-based information and navigation services. Operational management, I showed you the auto-correction and reporting, which can make big savings in smart maintenance and preventative maintenance. And the whole thing is based on open standards for interoperability and SIG mesh to follow. these are the building blocks that build up the picture which I've painted, and at this point I hand over back to Emre.